Hello, can everyone hear me? Hello, can everyone see me? Good. Good. So, लोग क्या कर रहे थे last time? Can anybody remind? What were we doing last time? और कर लिया था ना हमने रोटेशन प्लस ट्रांसलेशन कर लिया था फ्रिक्शन फ्रिक्शन वाले क्वेश्चन भी कर लिए थे ना फ्रिक्शन वाले क्वेश्चन we did or we did not केवल एक ही किया था okay उसको आज we'll finish it and we'll try to go beyond that today. Okay, let me just so hopefully now you can see the screen as well as you can see me, right? हाँ, this is a new setup because ये लॉकडाउन कब खत्म होएगा कब नहीं होएगा since I cannot go to that light board wala, that is also not possible. So hopefully this will be better. हाँ, okay. So whenever we talk about friction and rigid body dynamics, as usual, we want to talk about number one, the magnitude of friction. Number two, we want to find out or we want to talk about the direction of friction, right? Just, and number three, we want to talk about point of action of friction on the rigid body, right? So let's start with the magnitude of friction. Number one, the magnitude does not matter unless, okay, unless boundary condition is mentioned in the problem. So what do I mean by this? इसका मतलब क्या है? So generally, when we are going to talk about friction, as I hope we did in the last question that we did long time back, generally friction I'm going to take as F, F1, F2, F3. I am not going to be bothered with the magnitude of the friction force. Now, I want to tell you the reason for this, and of course, I want to tell you unless wala jo part hai. So, what happens is that when a body is rolling on a surface, okay, when a body is rolling on a surface, the the relative velocity of the body on the surface is zero. Okay, you remember I told you the condition of no slipping. What is the condition of no slipping? Well, no slipping is simply the fact that if you have a rigid body moving on a surface, then the velocity of this point on the body and the velocity of this point on the surface must be same. This is the meaning of slipping, right? So no slipping means that net velocity of this point on the rigid body and the velocity of this point on the surface, they are both equal to each other. Now, if the velocity of that point of contact of the rigid body is the same as the velocity of the surface, this means, okay, this implies that the relative velocity must be zero. Relative velocity must be zero. And if relative velocity between two surfaces is zero, then the friction acting between those two surfaces must be static friction and not kinetic friction. Okay, right? Now, again, I would like to be more specific about this. So, if you were to take your pen and if you were to put, if you were to paint it black, if you were to put paint on the pen, and then if I were to sort of roll it on my hand like so, okay, then on this hand, of course, you would see the streak of paint, right? Now, you will, I hope, agree that as I roll this pen on my hand, there will be a one-to-one correspondence between the surface of this pen with my hand. What this means is that as the pen rotates 2 pi, the length of the black line on my hand will be 2 pi r. Okay? This means that one point on the pen was in contact with one point of my hand. And as the pen moved forward, then another point of the pen was in contact with another point of my hand. But whenever they were in contact, there was no smearing of paint. Okay? The paint did not smear. हाँ, नहीं, 1-to-1 correspondence मतलब paint smear नहीं हो रहा है. मतलब ये ऐसे घिस के नहीं जा रहा है ऊपर. ये इस तरीके से ऊपर जा रहा है कि जब 2 पाई एंगल टर्न हुआ ये पेन, यहाँ पे जो लेंथ ऑफ ब्लैक पेंट है वो 2 पाई आर है एग्जैक्टली. इसका मतलब ये हुआ that the friction between my hand and the pen, as long as there is no, घिसना नहीं है, as long as there is no slipping, the friction between my hand and the pen is static friction and not kinetic friction. Now, this is counterintuitive because of the fact that the pen is moving, right? I mean, we can see there is motion. So this is counterintuitive because of the fact that there is motion, and I'm saying that look, static friction is acting. But static friction, जो हमने पढ़ा था, that was for point objects, and point objects do not have any linear dimensions. So if a point object is kept on a surface, and if I move that point object, right, then there is slipping. As long as the point object is stationary, there is no slipping. Now I may represent the point object, of course, by boxes and wedges and various other things, but at the end of the day, they were point objects. Now we are dealing with rigid bodies, bodies which have dimensions. So this guy, this cylinder, for example, has a radius, has a length. Okay, it has a surface area. So as I move the pen on my hand and it does not slip, as I roll the pen on my hand and it does not slip, okay, this means that wherever the pen is in contact with my hand, the velocity of the pen is the same as the velocity of that point on the pen. Now this itself is counterintuitive. What do you mean by velocity of that point? What do you mean by velocity of the pen? Well, velocity of the pen is something different and velocity of the point of contact is something different, right? We have discussed this. Velocity of the pen would be the velocity of the center of mass, end of story. But velocity of that point on the pen will be the vector sum of two velocities. That is velocity due to translation, which is nothing but the velocity of the center of mass. And the second is velocity due to rotation. AR and AT in case of acceleration, VR and VT in case of no acceleration, in case of just motion. So since relative velocity must be zero between the point of contact of the rigid body and the surface, this in turn means that static friction is acting between the pen लिख रहा हूं मैं, sorry, between the rigid body and the surface. Okay, and since static friction is acting, we know, so since we know that value of static friction between mu and 0. Therefore, I cannot, right? And please try to understand this. Therefore, I cannot tell you the value of friction despite the fact that the rigid body is moving. So the rigid body is moving, but the point of contact has zero velocity. So this guy has velocity v, this guy has velocity 0. And as I think we discussed, this guy will have velocity what? Topmost point will have velocity what? We have discussed this, right? मैंने आपको बताया हुआ है, सारे shortcuts बताए हुए हैं. Topmost point का velocity क्या होएगा बताइए? Please tell me.
2v.
And I could not yeah, VCM plus R omega. R omega in this case is V. So and I can prove this now. Look, I can prove this now. देखो, ये मेरा हाथ इसको रोल करके ऊपर जा रहा है. Please notice that my right hand was in contact with the top of the cylinder. My left hand is stationary and is contact with the bottom of the cylinder. Okay, we are saying this is the bottom, this is the top. So as I go up, okay, please notice that my right hand, by the time the cylinder reaches the top of my left hand, my right hand has actually traveled twice the distance And when my right hand is there with the left hand, then the cylinder has traveled half the distance. That is how we say that the velocity of the topmost point is 2. सर एक डाउट है, जब हम किसी ऑब्जेक्ट को वेज से रिलीज करते हैं देन नेट टॉर्क इज जीरो, देन हाउ ऑब्जेक्ट रोल्स डाउन इफ द टॉर्क इज जीरो? हम आ रहे हैं, वी आर कमिंग टू दैट, वी आर कमिंग टू दैट, जस्ट गिव मी 5 minutes, we are coming to that. So since I cannot tell you the value of friction, since we cannot decide the value of friction, right? Therefore, friction between rolling object and surface is F. It is unknown. Now, what do I mean by unless boundary condition is mentioned in the problem? What do I mean by this? So if however, we say that the rigid body just नहीं बाउंड्री नहीं ये बाउंड्री कंडीशन नहीं है सर, ये है बाउंड्री कंडीशन, just slips or just about to slip, वही सेम जो पुराना फ्रिक्शन, same as before, then friction will be mu n. Okay, so what I'm trying to say is that unless the question specifically mentions that the object is about to slip, unless the question very specifically mentions this, you are at liberty to forget about the magnitude of friction. You don't need to care about it. You can only write F1, F2, right? Whatever equations you make, if the question subsequently asks, please tell me the value of friction, no problem. You will take it as F1, F2. You will never take it as mu n, n1, mu n2. Take it as F1, F2. And the equations that you make, that is translation equation, rotation equation, constraint equation. After the equations you make, you can solve to find the value of friction. Of course, if in the question it is mentioned that the rigid body is just about to slip, then you will simply take the friction as mu n. Okay, this is sort of the same as before. So before, when we were in LLM, when we were doing questions, we were mostly interested in problems where slipping was just about to take place. So by default, we used to take friction as mu n. But here we have to be careful. Okay, please don't take friction as mu n. Just take it as F1, F2, unless of course the question forces you to take mu n as the value of friction. Okay, I hope this is understood. आ गया ना समझ में, इसमें कोई डाउट? लेस देन म्यू एन वाले केसेस बचे हैं ना? सारे केसेस रजत, मतलब 99% केसेस जो है वो लेस देन म्यू एन वाले होंगे. अभी हम बहुत सारे क्वेश्चन करेंगे, डोंट वरी, बहुत सारे क्वेश्चन करेंगे. अभी कहानी खत्म नहीं हुई है, अभी पिक्चर बाकी. Here also max value is mu n, therefore body is slipping directly. नहीं, हम slipping तो हमारे slipping is not going to come. I will discuss slipping at the end of the chapter. I believe HCV में एक question दिया है जो slipping involve कर रहा है. Slipping will be very rare phenomena that you will see. अगर स्लिपिंग हो रही है, yes, then friction has to be mu1. Because अगर स्लिपिंग हो रही है तो ये सब जो मैंने लिखा है सब गलत हो गया, because then relative velocity will not be zero, and if relative velocity is not zero, then static friction will not be acting, then kinetic friction will be acting. Okay? और हमें मालूम है kinetic friction की एक ही वैल्यू होती है, that is mu n. Kinetic friction does not have a range, only static friction has a range. Okay? हाँ, next is the direction of friction. Okay, number 2 is the direction of friction. Okay, so now finding the direction of friction uh, is not important. पहली चीज, it is not important. Okay? So not important to solve question. Okay? It is not important to solve the question. However, you might be asked directly, please tell us the direction of friction. So I am going to tell you two ways. One is sort of थोड़ा सा long method है, but it always yields the correct result. The other is a shortcut, but the shortcut is valid only for some of the situations, right? So let me first show you the long method. So the long method valid always. Okay. So in the long method, what is going to happen is that, and in the short method, both, you are going to find. Remember what we are doing. We are trying to find the direction of friction. Okay, we are trying to find where in my free body diagram where should the arrow of friction be drawn. So first, what you will do is you will draw the FBD without friction. Okay, so there's an incomplete FBD. Eventually, you will draw, I mean, in the same FBD, you will put in the friction wala arrow also. But first, you will draw the FBD without friction. Okay. Now, whenever I say FBD, I really mean rotational FBD. Okay, because अगर rotational FBD सामने है तो translation भी सामने ही. So let's say, let me give an example. So we have to find friction direction for the cylinder. Okay, so let me draw the FBD. We have orange, we have mg, we have n, and we have f. Okay, please notice that I have drawn no friction here. Okay. After you have drawn the FBD without friction, then find ACN and alpha. How are you going to do this? So F is equal to MACN. Please notice there is no friction, so It is not F minus F plus उससे कोई मतलब नहीं है. It is only in the absence of friction that I am calculating the ACM. But remember that whatever calculation I'm carrying out is ultimately going to change because there will eventually be a friction, right? So this whole exercise is so that I can find the direction of friction. Once the direction of friction is found, then I have to do everything again with friction arrow added on the FBD. And we have FR is equal to I alpha, which is equal to MR square by 2 into alpha. Okay. So I get alpha is equal to 2F by MR, and I get ACUM as F by M. अच्छा, oh, sorry. वो कभी कभी शेयरिंग बंद हो जाता है. Don't worry, I'll just share it again. कैसी फोटो लगा के रखी है भाई. रजत, ये तू ही है ना? नहीं, रजत नहीं है. कौन है? हाँ हाँ, एक मिनट रुको. लेट मी जस्ट रीशेयर. तो अपने हाथ में. Okay, so ACM is equal to F upon M, and alpha is equal to 2F upon MR. Okay, right? ठीक है ना? Now what you do is you go back to the diagram. Okay, you go back to the diagram and you find the acceleration of this point in contact. So the third step, find एक मिनट भैया, shared window कहाँ गई मेरी? Find the acceleration of net acceleration of point of contact. तो ACM F by M है, right? ACM F by M है. तो यहाँ पे आ जाएगा F by M. Right? This is what? This is acceleration due to translation of this point, right? And alpha की value है 2F by MR, and alpha is clockwise, as is obvious from this diagram, right? So if alpha is clockwise, that means that the acceleration of this point must be like this due to rotation. So the acceleration of this point is like this, right? And its value is how much? R alpha, which is equal to 2F by M. Okay? Capital F है यहाँ पे, which is equal to 2F by M. What is this? Acceleration due to rotation. And furthermore, I notice that this point has a net acceleration in this direction. So finally then, we can say that friction will be opposite to A net. Right? So what have I done? I forgot about friction. I drew the free body diagram. I found the value of acceleration of center of mass and alpha. And then I found out the net acceleration of the point of contact. Whatever is the direction of this net acceleration, the friction will be opposite to the direction of net acceleration. This means of course, that I go back to my original diagram, and, I write that this must be the direction of friction. So if I want to solve this question, then what I need to do is that I need to draw the FBD again and say that, look, F is acting like this, F friction is acting like this, mg is acting like this, normal reaction is acting like this, and now I can begin to write down the equations. So I will write down that for translation we have F plus F is equal to MACOM. Okay, and then I'll write down that for rotation we have Fr minus Fr is equal to I alpha, and then I will write down whatever constraints there are, and whatever I write down here, I will solve these equations and find the answer. But you see that you are doing lots of work here. What is the what is the uh, what is the work? What is the work that we are doing? What is the additional work we are doing? Well, you can see हमें बोला गया find the acceleration of this object. Let's say find the and we will do this question in a minute. Find the acceleration of the cylinder if the force F is applied on the cylinder. ठीक है भाई, करते हैं पहले, लेकिन मेरे को ये हुआ कि नहीं, मेरे को फ्रिक्शन का डायरेक्शन चाहिए. फ्रिक्शन का डायरेक्शन चाहिए, कैसे आएगा भाई? फ्रिक्शन का डायरेक्शन निकालने के लिए ये पूरी एक्सरसाइज हुई यहाँ से यहाँ तक. ये एक्सरसाइज इज ओनली टू फाइंड द डायरेक्शन ऑफ फ्रिक्शन, and once the direction of friction is found, okay, once the direction of friction is found, then I can proceed to do the question. However, you can do this question without finding the direction of friction. You can choose the direction of friction any which way you want. You can choose it forward, you can choose it backward. The answer that you'll get will not be wrong. That is the beauty of this thing. If both R alpha and ACM are in the same direction, then directly we can say that friction will be opposite to, yeah, absolutely, yes. अगर ACM और ACM और R alpha दोनों same direction में है, तब आपको सोचना ही नहीं है, friction will be opposite to that. Okay, चलो. So let's try and do this question. Find acceleration of cylinder. Also find the friction force. हाँ, ये सारे notes share हो जाएंगे. All these notes will be shared, so don't worry about it. I would prefer, of course, that you write, but I will share all these notes. Chalo. So try to find the acceleration now. Do it in. So I have already found the direction of friction, right? I have already found the direction of friction. So some of you take the friction forward, some of you take the friction backward, and you see that you'll end up with the same answer. Will not matter. करो. अरे स्मिथ तो अपना काम करना है। जो मैंने बोला वो कर पहले। फाइंड आउट द एक्सेलरेशन ऑफ दिस क्विकली, टेल मी द आंसर। अब वीडियो पे ही पढ़ाऊंगा, तेरा भी वीडियो ऑन कराऊंगा। मेरे वीडियो ऑन कर दो, ऑन कर वीडियो स्मिथ तो अभी चल। हाँ, जल्दी से करो भाइयों। वेरी गुड साहब, यस। स्मिथ तेरे आंसर में देख गड़बड़ है ना। इट इज हैविंग द रॉन्ग डायमेंशंस। ध्यान से। Okay, like I said, you don't need to worry about the direction of friction. Okay, if I can, so we have F. F. I can take the friction the other way around as well. Will not matter. I'm not really bothered about any other force because the whole thing is horizontal. Uh, because the whole thing is horizontal. So I write then for translation, we get F plus F is equal to ma. Then for rotation, we get Fr minus Fr is equal to mr square by 2 into alpha. And then the constraints. Now constraints is going to be, almost always it is going to be A is equal to RL. So if you are stuck and you don't know what to do, you have made these two equations and you are stuck and you don't know what to do, please just take A is equal to R alpha and proceed. Sometimes, of course, it will not be. I will make you practice those questions, but in the future also remember that if you get stuck, just take A is equal to R alpha and proceed. This point and this point must have the same acceleration. So this point has acceleration A due to translation, and it has acceleration R alpha due to rotation. This point has zero acceleration because it is on the floor. So A net is equal to A minus R alpha. So the way to talk about constraints is that since A minus R alpha should be equal to zero, right? What is this? What is this? This is the acceleration of point on a rigid body. And what is this? This is acceleration of point on the surface. हाँ, नहीं पार्थ f/2 तो नहीं आएगा फ्रैक्शन मेरे ख्याल से, f/3 आना चाहिए. देखो फिर से. So now I can write f plus f is equal to ma, and I can write f minus f is equal to ma by 2, right? r कैंसिल हो गया और अल्फा को a by r रख दिया, तो दूसरा वाला r भी कैंसिल हो गया. तीनों को ऐड कर दिया मैंने, दोनों इक्वेशंस को. 2f is equal to 3ma by 2. So I get a is equal to 4f by 3m. And if I know the value of a, then I know the value of f as well. So f is equal to ma minus f, which will be equal to 4f by 3 minus f, which is equal to f by 3. So this is friction, and this is acceleration. हाँ बिल्कुल सर. सोनल नहीं कर पाई क्या? राधिका?
सर थोड़ा अलग है मेरा.
अलग कैसे आ सकता है? क्या
सर
क्या
वो मिस्टेक मैंने कंस्ट्रेंट्स में लगाई थी.
constraints? Remember, if you are not getting it, you are confused, take A is equal to R. खत्म. वो A is equal to R alpha यूज कर लिया, लेकिन क्यों हुआ वो ये देखना. यहाँ लिखा है, देख, ये बॉडी इस हॉरिजॉन्टल सरफेस पे रोल कर रही है, तो ये वाला पॉइंट बॉडी का और ये वाला पॉइंट सरफेस का, इन दोनों का एक्सेलरेशन सेम होना चाहिए, है ना? हाँ, ऑपोजिट एफ लिया, माइनस में आया, माइनस में थोड़ी ना आएगा यार. हाँ माइनस में आ सकता है. हाँ अरे सेम इसलिए होना चाहिए जोहेब, नहीं तो स्लिपिंग हो जाएगी ना. अभी तब से तो मैं यही एक्सप्लेन कर रहा हूँ, इन दोनों का एक्सेलरेशन सेम होना चाहिए. ये देख, यही लिखा हुआ है मैंने यहाँ पे. कहाँ पे लिखा है? ये net velocity of this point or net acceleration of this point must be equal to velocity of this point on the surface. Opposite लिया अगर, तब क्या होएगा? Let's try this. So let's say that you are not bothered with friction कहाँ है, क्या है. So we take the f like this, f like this. हाँ नेगेटिव आ जाएगा, that's okay. नेगेटिव आएगा तो that's okay. So for translation, we will have F minus F is equal to ma for rotation. We will have F Fr plus Fr, right? Because ये भी clockwise है, ये भी clockwise, is equal to mr square by 2 into alpha, and constraints will be same. That is, A is equal to R alpha. Okay. So what are the things that we have to add? F minus F is equal to ma. F plus F is equal to ma by 2. You get the same result. 2F is equal to 3ma by 2. A is equal to 4F. Right? But of course, when you find out friction, when you find out friction, then you will say that uh, friction is equal to F minus ma, and that will be equal to F minus 4F by 3 minus F by 3. So this minus sign tells you that assumed direction of friction. That's it. Please notice that acceleration निकालने में तो negative sign भी नहीं आया. Most of the questions will actually ask you acceleration. Yeah, सबको समझ में is this understood? You don't need, the whole crux of what I'm trying to teach you is that you don't need to care about friction. Of course, it will be there in your FBD, but the direction does not matter. Magnitude does not matter. एक एरो बना दो F, दो फ्रिक्शन है F1 F2, काम खत्म. जहां मन है वहां बना दो. चलो next example. Please try to do this. All of you, please try to get this correct. ले दे के वही इक्वेशन लिखना है. कंस्ट्रेंट अगर नहीं समझ में आ रहा है तो A इज इक्वल टू आर अल्फा लिख के नक्की कर देना, खत्म कर देना. Okay, and this guy is an ideal pulley. Basically, ideal pulleys play no role. They're just fully ideal. Yes. So do this one quickly and efficiently. पे नहीं कोई लॉन्ग मेथड यूज नहीं कर, अनलेस आपको स्पेसिफिकली पूछा जाए कि मेरे को फ्रिक्शन का डायरेक्शन बताइए. Unless this statement exists, you don't need to do the long method or the short method, which I will tell you. Don't need anything. Assume a direction of friction. खत्म. Arrow बनाओ, F लिखो. आगे बढ़ो. बहुत बढ़िया. Yes. आदित्य एक बार चेक करना. I don't गड़बड़ लग रहा है, but you are on the right. Maybe you are right. तेरे को आंसर एग्जैक्ट याद है. Anybody else? केवल आदित्य ने किया. हाँ सुनो, करो करो करो, करो, आराम से करो. This looks like a more correct answer. Radhika. नहीं 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 don't. जोहेर सॉलिड स्फीयर है मेरे भाई, मत बोल के तू भूल गया। केवल मोमेंट ऑफ इनर्शिया की वैल्यू चेंज करना, सब कुछ वापस करने की जरूरत थोड़ी ना है। चल मैं शुरू करता हूँ। सो पहले let me assume some things. Let the acceleration of this guy be a1. Let the acceleration of this guy be a2. Okay. I will assume that the friction here is like this. Does not have to be, can be in the backward direction, does not matter at all. So first I write down for acceleration of m. Now since this is an ideal pulley, what this means is that if here the tension is T, here the tension must also be T. That is the only meaning of an ideal pulley. Unideal pulley T1, T2. Ideal pulley T, both sides. So for acceleration of m, we get mg minus T is equal to ma2. Okay. Then for translation of capital M, we get T plus F is equal to capital Ma2, A1, sorry, not A2. And then finally, for rotation of M, वो क्या क्या? अच्छा, एक for rotation of capital M, we get TR minus FR is equal to I alpha. And finally, constraints. Now again, I'm telling you, I will work it out. But if you are stuck, you don't have to work it out. I will tell you the questions where the constraint is not equal to, not A is equal to R alpha. Like I said, most of the cases it is. This point has acceleration A due to translation, has acceleration R alpha due to rotation. A1 है शायद, हाँ A1. So the net acceleration of this point, is equal to A minus R alpha, A1 minus R alpha. And the acceleration of this point is 0. Both must be equal. So A1 minus R alpha should be equal to 0. A1 should be equal to R alpha. A1 is equal to R alpha. And what can you tell me about A1 and A2? What is the constraint there? What can you tell me about A1 and A2? What is the constraint there? A1 and A2, what is the constraint? देखो चैट विंडो मेरी गायब हो गई। नहीं अभिजीत, गलत है। आंसर हो सकता है थोड़ा गलत हो। Please remember this. I think I did this. I will do it again. So देखो 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 यार, इधर देखो, इधर देखो अभिजीत। अगर इस पॉइंट का एक्सेलरेशन ए है, इस पॉइंट का 0 होएगा, इस पॉइंट का 2a होएगा। हाँ, अगर इस पॉइंट का एक्सेलरेशन ए है, रोटेशन ऐसे हो रहा है, ठीक है ना, इस पॉइंट का एक्सेलरेशन 2a हो जाएगा, इस पॉइंट का एक्सेलरेशन 0 हो जाएगा। अगर इस पॉइंट का एक्सेलरेशन ए है और रोटेशन ऐसे हो रहा है, तो इस पॉइंट का एक्सेलरेशन 2a हो जाएगा, इस पॉइंट का एक्सेलरेशन 0 हो जाएगा। आई होप you are seeing how this is working, everybody. I hope you are understanding this. So things to remember. ये आया समझ में क्या हो रहा है? अगर एक रिजिड बॉडी आपको हॉरिजॉन्टली मूव करते हुए दिखाई दे, इसका रोटेशन ऐसे हो रहा है, जिस डायरेक्शन में रोटेशन हो रहा है उसका टॉप मोस्ट पॉइंट का एक्सेलरेशन 2a हो जाएगा, नीचे वाले का 0 हो जाएगा। सिमिलरली अगर आपको नीचे ज्यादा दिखाई दे रहा है, रोटेशन ऐसे हो रहा है, लेफ्ट वाले का 2a हो जाएगा, राइट वाले का 0 हो जाएगा। क्लॉकवाइज होता तो उल्टा हो जाता है। वेरी इजी टू फिगर आउट। So basically the other constraint is that a2 is equal to 2a1. Now you must ask me how this is. I mean, I must tell you why this is so. So this is so because let me choose something very funky like this. This is so because the acceleration of this point and the acceleration of this point must be same. So acceleration of these 2 points must be same. Okay. Now, acceleration of this point, acceleration of this point is a1 plus r alpha, and acceleration of this point is a2. So we must have a1 plus r alpha is equal to a2. But a1 is equal to r alpha, we already found. So 2a1 is equal to a2. This is the other constraint which I have written here, which you can, again, you don't have to do. You can remember this. That's it. Okay. हाँ, string inextensible है, but between which 2 points inextensible है? It is inextensible between this point and this point, because इसके beyond तो wrapped है ना string, तो इससे आगे जब वो जाएगा तो string की length तो बढ़ी जाएगी। जैसे जैसे string unwrap होएगी, string की length बढ़ जाएगी। Again, you don't need to remember any of these things. ट्रांसलेशन का ये इक्वेशन, रोटेशन का ये इक्वेशन, कंस्ट्रेंट का ये इक्वेशन, खत्म कहानी, सॉल्व करो। मैंने बोला रजत कि ये पॉइंट, ये पॉइंट और ये पॉइंट का एक्सेलरेशन सेम होना चाहिए, बिकॉज दे आर कनेक्टेड टू ईच अदर बाय ए स्ट्रिंग। इसके बियॉन्ड, ये जो ऊपर वाला येलो पॉइंट बनाया है, इसके पहले तो स्ट्रिंग है ना, और वाउंड है ना स्फीयर पे, अल्टीमेटली वो जब अनवाइंड होएगी तो स्ट्रिंग का लेंथ बढ़ता जाएगा। So let me write these equations once again. mg minus t is equal to ma2. कंस्ट्रेंट है ना, ये रहा ना, ये लिखा है ना मैंने। ओके, t plus f is equal to capital M a1. I don't want to write a1. because I want to find A2, so I'll write A2 by 2, and then TR minus FR is equal to 2 by 5 MR square into alpha, but alpha is equal to A1 by R, but again I don't want A1, so I'll have to write A2 by 2R. So ये कैंसिल हो गया, ये कैंसिल हो गया, यहाँ पे 2 कैंसिल हो गया. Now the problem is that when I add these three equations, right, I am not getting rid of t, because जब मैं ऐड करूंगा तो फर्स्ट इक्वेशन में माइनस टी है, सेकंड इक्वेशन में प्लस टी है, ये दोनों तो कैंसिल हो जाएंगे, लेकिन फिर थर्ड इक्वेशन में भी टी है, वो नहीं जा रहा है. सेकंड और थर्ड में प्लस एफ और माइनस एफ जीरो हो जाता है, राइट. ये कौन है यार, अजीब सा फोटो लगाया हुआ है, ये बहुत वियर्ड है. ये कौन है ये? मैं बता रहा हूँ, ये रजत है ना, मेरे को मालूम था ये रजत है. ये रजत, फोटो हटाइए तो पहले, मेरे को लग रहा है मेरे को ही डांट रहा है. फोटो हटा रजत, नहीं तो मैं अभी तेरे को पीट दूंगा. So to get rid of this, what I do is to get rid of t. हाँ exactly, very good. I will. अब तूने लाल क्या मेरे को बैल समझाओ, क्या कर रहा है ये? वीडियो ऑन कर, तो चलो वीडियो ऑन कर, वीडियो ऑन कर, वीडियो ऑन कर. ऑप्शन नहीं है मेरे पास, भी ऑप्शन नहीं है. रिपोर्ट कर दूंगा तेरे को मैं, रिपोर्ट. ले चल, हाँ चल चल, आया ना? हाँ अब बेटर. तो जब मैं 2 से मल्टीप्लाई करूंगा तो when I add these three equations, what will happen is that I'll have minus 2t plus t plus t, ये cancel हो गया, plus f minus f, ये cancel हो गया. On the left hand side I'll get 2mg. On the right hand side I'll get a2, मैंने common ले लिया. I'll end up with 2m from the first equation, m by 2 from the second equation, and from the third equation I'll end up with m by 5, right? So I will get then 2mg is equal to a2 2m plus, क्या होता है भाई रजत, 1/2 plus 1/5?
7/10.
1/10?
7/10.
7/10. So a2 is equal to 20 mg, 20 small mg, divided by 20m plus 7m. Right? So the closest answer was that of Radhika. And I think Radhika, you forgot the factor of 2. A2 is
या सर मैंने दोनों ए लिखे, वहाँ पे गलत हुआ.
थोड़ा सा केयरफुल रहना प्लीज. रिमेंबर दिस डायग्राम, ये वाला डायग्राम है. और भाई रजत, समझ में आया तेरे को? पक्का है?
हाँ सर.
एक एक स्टेप समझ में आ रहा है? कोई ऐसा स्टेप है जो नहीं समझ में आ रहा है? प्लीज आस्क.
सर कंस्ट्रेंट लेने में प्रॉब्लम हो रहा है, वरना
कोई,
हो रहा है थोड़ा बहुत.
मैंने क्या बोला तेरे को? कंस्ट्रेंट में प्रॉब्लम हो रहा है तो क्या करेंगे?
वो ए आर वाला ले लेंगे.
A इज इक्वल टू आर अल्फा, कहानी खत्म. ठीक है,
यस सर.
चलो वन मोर.
सर इधर हमने A1 A2 लिया क्योंकि फ्रिक्शन है.
जोर से बोलना.
सर जो हमने दोनों का एक्सेलरेशन जो डिफरेंट लिया A1 और A2, वो इसलिए लिया ना क्योंकि फ्रिक्शन है सरफेस पे.
नहीं, वो इसलिए लिया क्योंकि ये वाला ऑब्जेक्ट का एक्सप्रेशन क्या होगा और ये क्या होगा, ये मुझे क्या मालूम. मतलब ऑब्वियसली बाद में मेरे को ये पता चल ही जा रहा है, लेकिन अभी इनिशियली मेरे को क्या मालूम कि दोनों का
सर
एक्सेस।
मतलब दोनों का सेम नहीं हो सकता, वैसा इशू नहीं हो सकता।
नहीं नहीं, same। क्योंकि ये रोल कर रही है ना बॉडी, ऊपर वाली बॉडी रोल कर रही है, इधर वाली बॉडी ट्रांसलेट कर रही है। हाउ कैन
हाँ
यू से?
सर।
नहीं, कभी भी वो ऐसा असम्पशन ही मत लो जो जो डिस्प्यूटेबल हो। व्हाई डू यू नीड दैट काइंड ऑफ एन असम्पशन?
नहीं सर, वो पुलिस में जब दोनों ऑब्जेक्ट ऊपर नीचे कर रहे थे तो हम ए लेते थे ना, इसलिए।
हाँ, जब दोनों ट्रांसलेट कर रहे हैं तब कोई इशू नहीं, देन ऑब्वियसली यू डू। हमने हमने लास्ट क्लास में कौन सा क्वेश्चन किया था? ये वाला तो नहीं किया, प्लैंक वाला तो नहीं किया था? प्लैंक से पुश कर रहे हैं सिलेंडर को, वही वाला था।
हाँ सर, वही किया था।
हाँ सर, किया था।
जो प्लैंक से पुश कर रहे थे ना सिलेंडर, वही किया था ना? ओके, सो चलो ये वाला करो। कंपोनेंट्स हम कभी यूज नहीं करेंगे भाई रजत। रोटेशन में यू विल फाइंड दैट देयर इज नो यूज। F by m आ रहा है क्या? So friction so for translation F plus F is equal to ma rotation Fr by 2 minus Fr is equal to mr square by 2 alpha, right? And A is equal to R alpha. So F plus F is equal to ma. F by 2 minus F is equal to ma by 2. And you simply add these two values. 3F by 2 is equal to 3ma by 2. A is equal to F by 2. End of story. Very good बात है, बहुत बढ़िया सर. Yes. नहीं रजत, 15-14 कहाँ से आ गया तेरा? क्यों डरा रहा है? सिलेंडर है बच्चा. कहाँ गलती करी है मैंने, बता. रजत, तेरी गलती है ना, मेरी तो नहीं है ना. दैट्स ओके, दैट्स ओके. ओके, ठीक. चलो ठीक है guys, I'll stop here and see you in the next class. अब ये थोड़ा सा और फास्ट हो जाएगा, right? I will share the whole thing. हाँ, तो अभी हम HCV के थोड़ा सा बियॉन्ड चले गए हैं. Questions that we'll be doing will be beyond HCV. However, next topic that we do, then again you can come back to HCV. HCV तो बोला था ना मैंने, 40 समथिंग तक करना है, बस वही है, वहीं तक. अगर A नेट 0 है तो फ्रिक्शन 0. हाँ बिल्कुल सही बात. A नेट 0 होगा तो फ्रिक्शन 0 होगा. हाँ वही मैं बोल रहा हूँ ना, ये हम HCV के आगे चले गए हैं. नहीं, 40-42 के बाद जो है नहीं करना है. नहीं, एंगुलर मोमेंटम जहाँ से शुरू होता है वहां से. इसकी प्रैक्टिस के लिए मैं भेजता हूँ. ये बुकलेट में होंगे क्वेश्चंस. चलो ओके, I will see you then in the next class. Okay.